Hi guys, Ms. DeLitto here. We're going to take a look today at factoring the greatest common factor using the area model. We've looked at this model when we were writing equivalent expressions or simplifying expressions using the distributive property. And now we're going to work in the opposite direction where we're going to expand expressions to write equivalent expressions. We know that right now we're looking at the sum of 5x and 35. If we think about this as the sum of the area of these two rectangles, we can write 5x as the area of the first rectangle and 35 as the area of that second rectangle. In order to factor our expression, we want to think about what these two terms have in common. So we can think about the factors for 5x and the factors for 35. A reminder that factors are numbers that are multiplied together to get another number or the product. The factors of 5x are 1, 5, x, and 5x. 1 times 5x is 5x, 5 times x is 5x. The factors of 35 are 1, 5, 7, and 35. The biggest factor that these two have in common would be 5. So our GCF in this case is 5. The greatest common factor will serve as the height of our rectangle. In this case, that greatest common factor is 5. Now we want to think to ourselves, 5 times what will give us the area of 5x? So 5 times x gives us the area of 5x. 5 times what will give us the area of 35? 5 times 7 gives us the area of 35. We know in order to find the area of a rectangle, we're multiplying the height times the base. And in this case, we know the base has to be whatever x is plus 7, or 5 times that quantity of x plus 7. This is our factored expression. We can check to make sure we factored correctly by going back and using distributive property. So 5 times x is 5x. 5 times 7 is 35. Let's take a look at another example. The next example that we're going to take a look at is 3x minus 21. Similar to the first example, we're going to start by plugging these in as the sum of the areas of these two. So the first term I see is 3x. That's going to go inside the first box. The second term that I see is negative 21. That's going to go in my second box. We need to think about what is our greatest common factor between these two terms. And in this case, that greatest common factor is 3. Now I'll think to myself, 3 times what is 3x? 3 times x is 3x. 3 times negative 7 is negative 21. So my factored expression is 3 times the quantity of x minus 7, where our GCF is always that term on the outside of our parentheses. One more example. The next example we'll look at is negative 3x minus 15. We're going to start by circling the terms that I see in my expression, negative 3x and negative 15, and the first term will go in the first box, and the second term will go in the second box. When I think about my greatest common factor between these two terms, I not only want to think about numerically what is that greatest common factor, but I also want to think about how can I pull the most out of these two boxes. So I know the greatest common factor between 3x and 15 is 3, but because I want to pull the most out, I want to also pull out that negative. I'll think to myself again, negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. To write my factored expression, my GCF, which we said was negative 3, will go on the outside of the parentheses, and x plus 5 will go on the inside. So negative 3 times the quantity of x plus 5 is my factored expression. One last example. For x minus 10. Again, I'm going to start by circling the terms that I see in my expression, and I'll place them inside the boxes. So 4x and negative 10. Now I have to think again, what is the greatest common factor between these two terms, 4x and negative 10? In this case, the greatest common factor is 2. And I'll think to myself again, 2 times what is 4x? 2 times 2x is 4x, and 2 times negative 5 is negative 10. So my factored expression will be 2 times the quantity of 2x minus 5. And again, we can go back and we can check to make sure we're correct by using that distributive property. 2 times 2x is 4x. 2 times negative 5 is negative 10. We want to make sure we've also factored by the greatest common factor by looking inside of the parentheses. If I see that there is a greatest common factor that is bigger than 1 that 2x and negative 5 share, that means that I have not factored by my greatest common factor. If the terms inside the parentheses do not share a greatest common factor other than 1, then I know I have factored by that greatest common factor.